GitHub repository for the week 1 exercise, Soccer Team Management app. Here we can find all the files and necessary documents. And now if we go to the project and into the Soccer entity app here, and here every entity in this app implements the Soccer entity interface. It defines two methods, get id and get name. This is important because the generic repository class uses this interface as a bounded type parameter, meaning only classes that implement Soccer entity can be stored in a repository. And if we go to the team.java from model, if we go to the this team.java from model, we can see it is the team class. It implements the Soccer entity. So it must provide get id and get name. So I also added the validation in the constructor. If the name, country or the leak is empty, it throws an illegal argument exception. And here this is the error handling requirement by the assignment. And if we go to the repository.java here, so this is the core generic class of the project. This the type parameter t extend the Soccer entity. That's a bounded type parameter, meaning t must be a Soccer entity. So that's the get all method. It returns a copy of all stored item. That's the add method. It stores an item and throws an exception if null passed. This is the filter method, and this is the most important method because it takes a predicate which is a functional interface, meaning the caller passes a lambda expression here. The method uses the stream API to filter items and returns a new list. If you go to the team repository.java, it extends the repository of the team and it adds a filter by leak, this one method, which internally calls the generic filter method and passes a lambda team arrow. Team.getLeak equals ignore case. This one, that lambda is evaluated for each item in the list, and this is the lambda usage number 1, a predicate lambda passed to the generic filter method. And now if we go to the custom iterator, this is my custom iterator interface. It defines two methods, hasNext, which returns true if there are more elements, and next, which returns the next element. And if we go to the team iterator implements this interface for team objects. It holds a list of teams and an index called cursor. If we go to the hasNext, so hasNext checks if the cursor is still within the list bound, and this is the next method. And next returns the team at the current cursor position, and it increments the cursor if there is no more items. It throws a no such element exception, like this. And if we go to the Soccer view model and go to this iterate teams with custom iterator method, here I demonstrate the iterator being used. I create a team iterator, then use a while loop. While hasNext, call next, exactly the iterator pattern. If we go to the data provider from here, the data provider contains all hard-coded sample data. It has 3 methods: create sample teams, create sample players, and create sample matches here. Each returning a list of objects. There are 3 teams, 12 players, and 8 matches shown in the app. And if we go to the Soccer view model again, this view model is where most of the lambda expression are used. It holds the 3 repositories and exposes live data that the fragments observe. If we go to the for each at this constructor, I load data from the data provider and add it to each repository using for each with a method reference data provider dot create sample teams dot for each team. Team repository double colon add. The double colon syntax is a method reference, which is a type of lambda expression. And if we go to the search teams, the search method uses the generic filter method from the repository and passes a multi-field predicate lambda, and this single lambda checks the team name, league and country all at once. If any field contains the search query, the team is included. And this is the lambda usage number 3, a predicate lambda for real-time search filtering. And if we go to the sort teams here, this sort method uses comparator lambdas with the stream API. Comparator dot comparing takes a method reference, for example team double colon get name here, which is a lambda that extracts the field to sort by. The stream is then sorted and collected back into a list. This is the lambda usage number 4, a comparator lambda for sorting using a stream API. Then if we go to the fragments from here, and if we go to the teams fragment, this fragment observes the view models live data when the list changes, either from a search or a sort. The observer callback fires and updates the recycler view adapter. And if we go to the observe call, observe call here, this lambda here, team list arrow adapter dot update data, this is observer. It runs every time the view model pushes new data. And then if we for next there is a sort buttons also use lambda click listeners, v arrow view model dot sort means short clean no anonymous classes needed. And now if we go to the main activity, in main activity the search bar uses a text watcher. The after text changed method checks which type is currently visible and routes to the search query to the correct view model method. And this is how one search bar controls all 3 tabs. To summarize, I implemented a generic repository class with a bounded type parameter, a costume iterator interface, and the implementation, a data provider with hard-coded data, and multiple lambda expression including predicate lambdas for filtering, comparator lambdas for sorting, method references, and observer callbacks. The app displays teams, players, and matches with live search and sort functionality.